We've been 39 minutes-ish. Still cooking. Still cooking. All right. So our program's still running after 40 minutes. When the greatest common divisor version of this ran basically instantly. All right. So I'll let this cook for a few more minutes as we're still talking about some stuff. Now, what we want to transition toward now is what's next. So if we talk about arrays, let's talk about weaknesses of arrays. Last time we talked about arrays as being, the positives of it, or at least, what did it give us? What did it bring to the table for us? Was it gave us a single variable name that allowed us to store multiple values under one variable name, and they're also fast. We talked about that last time where walking through memory was computable, right? Okay, we can compute it and walk through memory. So they're really, really fast from a performance perspective. Now, what would you say are the weaknesses of arrays?
You can't change the value. I mean the size of the array.
Okay, fair enough. So arrays are fixed in size once they are created. Fair enough.
And
What else?
If you want to change one of the values, you have to create a new array, right?
If you want to change a value that's already in the array, no. If you want to add a new value, you have to create a new array because they're fixed in size once they're created. So if you create an array that has 10 elements in it and you want to add an 11th, you have to burn down the house, build a brand new house with the back porch. Okay? So, if you want to add more stuff than the array was originally built to hold, you have to build a brand new array.
Not about adding. Let's say one of the values I want to change it instead of 5. Let's say A5.
Yeah. So you want to change bucket 3 from being a 7 to a 10.
Will that create a new array?
No. That's fast. That's high performance. No problem. No harm, no foul. Okay. So one weakness certainly is arrays are fixed in size once you create them. So make sure you make them big enough to hold everything you think you might need to hold right off the bat. Now, for our fractions, that wasn't a huge deal because we only had to hold 2 pieces of information, numerator and a denominator, right? Okay, so no harm, no foul. Create a 2-bucket array. That's how many buckets I need is 2. But I'd like to be able to refer to that under one variable name. So that's the advantage of an array gave us, right? Okay, what are other weaknesses of arrays?
Array has the elements are in the same type, the data type.
Okay, fair enough. All elements must be in the same data type, or of the same data type. Okay. And there's a little bit of wiggle room we could talk about in here because we could store generic objects in an array. But let's forget about that for right now. We'll be in a better position to talk about the details of that when I introduce objects. Okay? But for right now, this is a fair statement. All elements of the array must be the same type. We either have a whole bunch of ints, or a whole bunch of floats, or a whole bunch of booleans, or a whole bunch of big integers. Okay? And by the way, notice we looked at that today. Prior to this, we've always created arrays of primitive types. We had arrays of chars or arrays of ints. I think we had an array of strings maybe one time, right? That's an object. Well, today we created an array of big integer. So you can create an array of any data type that you can create a variable of. Okay? But as he pointed out, all the elements of your array must be of the same data type. So that's a limitation, right? If I need to hold 2 integers and a float, I can't do that in an array. I either have to create an integer array or a float array, or double array, whatever you want to do. I can't just say bucket 0 is an int, bucket 1 is an int, and bucket 2 is a float. That makes sense? So that's a limitation. What else? Both of these are good. These are.
Hard to find the content in the array because you cannot don't know the content from the name.
Yeah, you kind of have to remember where stuff goes, right? So in our case, we had a fairly simple example with our homework with the fractions. It wasn't that big a deal for us to remember that the numerator was at bucket 0 and the denominator was at bucket 1. Not a big deal, right? Okay, but what if I had to keep track of 30 pieces of information? Somewhere you're going to have a little mapping and some documentation that says, okay, bucket 0 holds the first name. Bucket 1 holds the last name. Bucket 2 holds the social security number. Bucket 3 holds their phone number, so on and so forth, right? So we have to keep track of the position of the various elements in the array that have meaning to us. Okay, now understand that arrays aren't always used for that. In fact, arrays initially, the original purpose of an array was to hold collections of data, like a whole bunch of numbers. So we might have an array and we want to take the average of all the numbers in the array, something like that. So each element of the array didn't necessarily represent a first name or a last name or something like that. It was just a collection of numbers. And we're going to do something with that collection of numbers. Maybe we sum them all up, maybe we take the average, whatever it is, something like that. Okay? In an example like that, we don't have to know what bucket 4 represents. We just have to know that bucket 4 holds an integer, right? We don't have to remember somewhere that bucket 4 is actually the latitude coordinate of something else. We don't have to remember that kind of information. So arrays are perfectly suitable for that. Just collect, if we have to hold 100 numbers that we want to be able to refer back to later on, they're perfect. Arrays are perfect for that. But as our programming started getting more complex, we started seeing some weaknesses in our older programming paradigms. And this goes way, 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 way back. To this slide. There are 3 types of programming languages. Forget about functional. Let's pretend like they don't exist for us there. Functional languages are actually a blast, but in our context, it just confuses things. Okay, procedural and object-oriented. Our older language, like C, was a procedural language. And really, the stuff I'm talking about right now, where we start hitting our limitations of arrays, comes from C. C had everything we've learned up to this point in this course built into it. Okay, we have not done one object-oriented thing in this course, minus using a couple of objects. Okay, but in terms of our problem-solving approach, nothing we've done in here has been in terms of objects yet. So we might as well have been C programmers up to this point in this course. Make sense? Procedural is procedural. Now remember, if you had to remind me, what's the difference between a procedural language and an object-oriented language in terms of the telephone? I usually point over here. This is where the telephone lives, right?
Procedural language shows all the details, like the cables, I don't know what. Object-oriented is just like smartphone. They already exist. You just have to put them.
Sure. And you know the wires are there. So the procedural version of a telephone is a pile of wires that has all the crap that we never have to deal with again after it's built, plus all the crap that we deal with on a regular basis, all exposed. The object-oriented version of the phone has all those details that we never have to deal with encapsulated inside of a plastic container or something, and only the public interfaces, the part of it that we have to interact with, are exposed to us. Okay? They both are solving the problem of the telephone. But the C version of the telephone has all those wires. The C++ and newer language version of the telephone looks like a phone object to us. It's an evolution of programming languages. Okay. What's this?
A sleeker version?
A sleeker version's fair. Okay? But when I say it's an evolution of programming languages, what does that really mean? What's the job of a programming language? Okay, give me a little more. The programming language does not solve problems.
Yeah.
The human being solves the problems.
Make it easier for us?
Okay, I'm liking where this is going. What do you mean by making it easier for us?
Easy to code. Long before there was machine coding, we used machine language.
Okay, so it's easier to code. So the quality of a language is based on the quality of the syntax?
How easy it's understood by people. How easy it's to code. How many functions you can do using that. Instead of writing everything, you can just pull it from the libraries that already exist.
Okay. I don't think you're far off, but I think you're missing what I'm looking for by a little bit here.
In programming languages is a way to communicate with the computer.
Okay. So if we think about natural languages.
To mimic the way for human beings to
Okay, so I mean that's really what it is. The job of a programming language is to mimic the way human beings solve problems, so that we can solve problems and tell the computer what to do. Okay, the programming language itself is a tool that tries to capture how we solve problems. All right, as opposed to being one language is like, oh, I like the syntax of this language better than the syntax of this language. Okay, and when we talked about this at the beginning in terms of natural languages. So the only language I know is English and bad English. Okay, and I know a little bit of Spanish, like 2 semesters of it, something like that. Okay, now many of you in here are bilingual. Probably have some people who are trilingual. Anybody know more than 3 languages fluently, or just know of them?
I know fluently. Urdu, Hindi, Telugu, and English.
Well, isn't Urdu and Hindi like the same language?
They seem same, but they're not the same.
Yeah, but when you live in India, you're forced to learn both of them.
You just learn it. Most people
Okay, so you know Urdu, you know Hindi and English.
Yeah, and a regional language, Telugu. That's my mother tongue.
Oh, okay.
I know it.
What, Telugu?
Telugu.
Telugu?
You can't pronounce it. Telugu.
Telugu?
Yeah, Telugu.
What country is that?
I mean, Andhra Pradesh. It's a state in my country.
State in India?
India has like 1,200 official languages.
It's like made up.
No, there are 4,000, 5,000 languages. It's only 1,200 official.
Why?
Because there's so many languages.
I mean, those are like gangs, right? Every little city has their own little gang language.
Gangs have their own languages too. I mean.
So like, what happens when you go over to like, if you're driving 25 minutes to another town and all of a sudden you can't speak their language?
No, you can speak. I mean, the states are really big. It's like south of Wisconsin. You can speak the entire language here.
Okay, so but the second I go down to Illinois, you can't understand them?
You can speak Hindi. That's the natural language. So
Okay, so that's the common language.
So they have
English.
some languages.
All right.
English, everyone, mostly.
Okay, so basically Hindi is the real common language. English has become the adopted common language. But then each state kind of has their native language that everybody there knows and speaks amongst each other, and then they fall back to Hindi when they are in mixed company. Is that the thing? I guess it's the same thing here. When we say bad English, I mean, like, when if you're from Wisconsin and you're talking to somebody from Louisiana, you're both speaking English, but stuff's coming out a little different, right? Okay. But the important part of this is that when we talk about natural languages, whether it's Hindi or it's English, it's solving the same problem. It's providing the tool for us to communicate with other human beings. It would be very difficult outside of preference for us to say that English is better than Hindi or Hindi is better than English, right? It becomes a preference thing. What do you know and that kind of stuff. It's not that one necessarily solves the problem substantially better than the other. They're both for communicating with people. I suppose you might, well, actually, I'm guessing English probably wins now. I suppose you might be able to say that Hindi wins because it's got a larger population, but realistically, when you consider what percent of the world now speaks English, we've probably bypassed. But certainly in the United States, English is spoken outside of the United States now. Well, in England, but they don't count. They only made up the language. All right?
English is a fairly new language, like 1550?
Got to be older than that.
15. I saw the documentary.
Well, I mean, they've spoken English in England for...
Just from the 15th century.
So before that, it was whoever the inhabitants were, French or something?
Oh, yeah, French and German.
Yeah, that makes sense.
That's why it's called England, English land.
Yeah, that makes sense. But regardless, those are our natural languages, right? Their purpose is to solve problems so that we can communicate with other human beings.
We can make the computer understand better.
Okay. So when we talk about the evolution of programming languages, though, the language, I mean, when we're talking to a computer, it's like we're talking to a baby. Okay? It's like we're talking to a baby. We're not talking to a fully functional adult. Okay? Imagine how hard computer programming would be. I know some of you find it hard now, but imagine how hard it would be if we were trying to teach a person what to do, given all the things that a human being can do. Computers can just do a little tiny subset. Here's the list of magic tricks that a computer can do. And when we're solving problems, we're solving them in terms of those magic tricks. But now what we really like looking at here is the evolution. up to this point, we've all been C programmers. Okay, as we're sitting in here. Even though we're using Java syntax, we're doing C-style problem solving. Okay? And now we've hit a problem. We look at this fraction problem, we're like, you know, I kind of need a way of representing fractions. Now, in an older language like C, we would not have represented a fraction in an array. In C, we would have used something called a struct. Okay? We use something called a struct. So we would have said something like, let me do it in a text box. I'll just rough it out here a little bit. So we would have said struct fraction int numerator int denominator. All right, so we would have created our own little data type. So built into the language, we have ints and chars and booleans and things like that in C. But then we come to this problem like a fraction. We say, you know, I really need a way of representing fractions. So we would have created our own data type of type struct named fraction. Okay? And from that point forward, I could have created a fraction. Well, in C, it would have been fraction pointer. Actually, it wouldn't have been a pointer. Fraction f1. And then I could have said f1.numerator is equal to 1. f1.denominator is equal to 2, something like that. All right, so it would have allowed me to create a data type like this. And right off the bat, we're seeing one thing being solved. That was a problem with our arrays. And that is, we don't have to remember what was that bucket 0 or what was that bucket 1. Here's our fraction struct. f1.numerator is the numerator. f1.denominator is the denominator. That makes sense? So we might say a struct is the next evolution past arrays. Because just in the past little bit, we talked about a couple of different uses of arrays. If we just need to hold 100 random numbers, we don't need a struct for that. That's an array. I'm going to create an array capable of holding 100 numbers. We'll throw 100 numbers in there, and when I need them, I'll go and get them. Okay? The number that's in bucket 5 is no better or worse than the number that's in bucket 13. They're just numbers, collection of numbers. Okay? That's what an array is. But now when you start using an array to store other things, so you're taking advantage of this tool you bought at Home Depot that has several buckets in it, and you decide, okay, I'm going to put this stuff in bucket 0, and this stuff in bucket 1, and this stuff in bucket 2, an array becomes maybe convenient. You just have to remember what was in each bucket, right? But as you pointed out, the problem is all the data types have to be the same. With a struct, we could also just throw in another data type like a Boolean. For no good reason, it doesn't make sense in the fraction world, but we added it anyways. So now this one struct can hold an integer, another integer, and a Boolean. So right off the bat, this is better than an array, because I don't have to hold all the data types are the same. I can hold 2 ints and a bool in this one struct. Okay, so structs allow us to define our own data types. They don't exist in Java though. Okay, structs don't exist in Java. And there's a good reason for it. Java jumped. Okay, they went right past structs because structs are actually something that were in C. So, but there's a weakness here. When we talked way back at the beginning about variables. So here's variables. Somewhere we said there are 2 types of variables, right? Did we say that anywhere? Doesn't matter. I'll just say it now. Okay, so variables come in 2 flavors, and we've seen both of them. We've seen our primitive types, and we talked about these, right? So these are the basic types built into the language that are only capable of holding a value. That's all a primitive type can do. It's just hold a value. And now we have object types. like strings, like big integers. Okay? Object types can hold 0 or more values and potentially do more. When I say potentially do more, what am I really talking about? So a big integer can hold one value, right? It holds a representation of a number. So when we created a big integer today, we passed in a string representation of a number, 127. That's the value it holds, is the number 127, in whatever internal representation it stores that in. Okay, but it's holding that value. But was that all that big integers could do? They could do more than that. What else could they do? They had methods. They could add and subtract and greatest common divisor. They had all these magic tricks they knew how to do. Okay, so when we say that objects can hold 0 or more values, that is, an object doesn't have to hold a value. Often they do, but it doesn't have to. But they could also potentially do more than just hold values. And what we mean by that is methods. Okay? That is the evolution. That's the jump between a procedural language and object-oriented languages. Way back here, we had our C programmers, and we were having the growing pains to jump to C++. So we still had our procedural language. What you started seeing is you started seeing C programmers take this idea of a struct and start hacking it to the next level. So what they would do is they would have a function somewhere else in their program. And let's say we had a numerator, a denominator, and then we had a int pointer. Actually, let's do, we'll say fraction pointer add. Fraction f1, fraction f2, something like this. Now, the reality is this was not allowed in a struct. Instead, what you had to do is you had to write this function someplace else. So maybe before the struct. So you'd write that function, you'd have whatever it does inside of there. And then down here, you would create a pointer to a method. Now, in C, you had the ability of direct control over memory. So essentially what you would do is you would create a function pointer to our add method. Okay? Doesn't matter what the syntax is, but you would have three variables here. One was an integer called numerator, one was an integer called denominator, and one was a pointer which points to a function called add. And if we follow that pointer, which goes to a function, we could then use that function. It was like a hack to be able to use other functions from within a struct. Okay? So what you saw the programmers doing is you saw programmers evolving ahead of the languages. So as a programmer, we started saying, you know what? This concept of an object, before they were called objects, right? This concept of an object that is a collection of values, stored values, as well as methods. Okay? That concept is needed now. And we don't have a language that supports it. So the C programmers figured out how they can manipulate the tools available to them in the current language through structs and through memory pointers to actually create a pointer to a function, which allowed them to sort of kind of hack having a struct which contains variables and methods, variables and functions. It was procedures and functions back in C. Now it's called methods in object-oriented languages. Same crap. Same crap. All right, so these were the growing pains of that. When C came out, or when C++ came out, what it did is it took this idea of a struct, okay, this idea right here, and it said, you know what? Let's wrap this into something else. So we're going to go up one level of abstraction, and we're going to create something called a class. All right, so the class for our fraction here, actually let me just steal this. It's already formatted the way I want it to be formatted. instead of struct fraction, we're going to say class fraction. And inside here, we'll have our couple of variables, and we'll also have our methods. Okay, don't worry about what it's returning. This is fine. All right, so now we have something called a class instead of a struct. So you can almost say that class and struct are synonyms. Okay, but the word class specifically is associated with object-oriented languages. Okay, so when they came out with C++, they said, you know what? We need to do something that is a more modern version of a struct. Structs have been very good to us for a long time, and they're still used today. Anytime you're using old C and C++ libraries, and even in C++, structs were very, very, very common in C++. So classes, objects, are not necessarily a replacement for structs, although Java would say otherwise. Okay? Evidence would be that Java thinks structs don't need to exist because classes can basically do what a struct does, and that's true. That's true. But in the early days, a class was not necessarily a replacement for a struct. A class really was a replacement for this new bastardized version of a struct, which was the one that had pointers to methods. Make sense? So these programmers were stretching the original intended use of a struct beyond where it should have been. So now we had this idea of a class which had a name, and the class would have fields in it, variables just like structs had, but they also allowed us to have methods. Okay? But methods defined properly as opposed to a hack to include methods. All right? So we can say that a class is a superset of a structure. So a struct is just a collection of variables. So it's the ability to hold multiple variables of different types. So already a little upgrade from an array, correct? But classes add the additional functionality of being able to associate methods with those values. Okay, so it's a superset. It gives us a little bit extra ability. All right, so in C++, the idea of a class was created. We still had structs. C++ still supported structs, so if you wanted to create a little variable, a little data type for a XY coordinate, for instance, in iPhone programming, there's something called a CG point. Okay, so a CG point P dot X is equal to 5, P dot Y is equal to 7. Now I'm telling you this is ObjectiveC code. Okay, I'm also telling you that if you were to make CG points 15 years ago or 20 years ago in C++, it would have looked just like that. So when you're using ObjectiveC, this other language, way back up here, it's a little bit farther down on the totem pole. So here's our ObjectiveC down here. We actually have a ObjectiveC 2.0 version right now. Okay, and now you have a new language, right? Now you have Swift. You have the Swift programming language. Okay, Swift's not just for iPhone. Yep, Swift is anything Mac. Anything Mac. So is ObjectiveC. This is Mac, this is Mac, this is Mac. Okay? It's actually quite interesting because it's very related to what we're talking about right now. That is, we had C, there was a need for object-oriented coding. There was a need to upgrade from structs to classes. Okay? So see, we've come back to what we talked about at the beginning of the class, but now we have some context. We're like, oh, I see where this is going. So before we had our object-oriented languages today, we were stuck at structs. So our experience in here has been we've gone as far as say, let's store some crap inside of an array and just keep track of what's in there. So now we can take it one step further and say, oh, I see the need for structs. I understand that it would be helpful for us to have our own data type called fraction that could hold two pieces of information, a numerator and a denominator. That would be of benefit to us. I'm telling you that an old language like C supported that. But even that wasn't enough because sometimes we need to do more than just hold values. Sometimes we need to also be able to do operations on those values. That's where those methods come in. So I'm telling you that back, those C programmers, in the early days before we had our modern object-oriented languages, they started really pushing the envelope, stretching the language to its limits. So that's when C++ came out, where it introduced this new data type called a class, which was a structure, which was a struct on steroids. Okay? Or really what it was the version of a struct that the modern C programmers were using, done in kind of an official way. Okay, so rather than having to create pointers to functions, you could just put the function in there, like you really wanted to do. Because you really wanted to have a struct that could hold a couple of variables and then also have a couple of functions. That's what you wanted. Okay? You had to pull that off by taking this backwards hack approach, because C only lets you store variables inside of structs. So now we introduce this idea of a class, which allows us to have variables and methods. C++ and Objective-C were both object-oriented versions of C. And if you remember back to our discussion with this was Apple, this was Microsoft. Right? They don't like each other. Right? And today it's what? Apple, Google. Which is fine. We benefit as consumers. We like there to be competition. We don't want Google to be a clear-cut winner or Apple to be a clear-cut winner. Right? You know, Google is never going to compete with Apple in terms of marketing. Okay? Apple is never going to compete with Google in terms of what's the opposite of innovation but still educational? The fact that, well, definitely search. Nobody's going to compete with Google in terms of search. They have too much of a head start. Even if a search engine came out, like that's their Bing commercials, right? You know, I think most of our recent tests that compare Bing to Google, I think people are typically impressed.
Email.
Huh?
Email. Gmail ones. Email.
Yeah. But I mean, you know, search would be a good example here. This is really marketing. I think you could make an argument that Bing is better than Google for searching.
Sometimes.
Yeah, some people have had that experience. But will Bing ever replace Google as the top search engine?
No.
Too little, too late, right? Nothing's gonna supplant Google until the paradigm of searching shifts, right? And we've seen that in our computing, our desktop computing. Nobody's gonna supplant Microsoft as the king of desktop operating systems.
Or if Google goes down for 10 days.
Even then.
Okay.
Okay. But the point is that now Apple sells more laptops per year than all the other laptop creators combined. Great. So that means you have zillions and zillions and zillions of people running out every single day who are running the Macintosh operating system instead of Windows. Does that mean that the Macintosh operating system is almost caught up to Microsoft in terms of their install base for Windows? Not even close. Not even. There's countries that he hasn't heard of. Okay? There's countries that he hasn't heard of that have thousands of machines that are running Windows. All right? So, but what's happened? These modern operating systems, so the Mac OS keeps evolving, but it's not that the Mac OS is really catching up. You're seeing the Mac OS and iOS, the mobile operating system, become closer and closer together. Because eventually you're going to see a paradigm shift. You're already seeing it, where we're moving away from the idea of desktop computing to mobile computing. Already it's more common for people to have a laptop than a desktop. Well, that was not the case 10 years ago. 10 years ago, you probably at least had a desktop. Maybe you had a laptop, right? Now, how many of you in here have a laptop but not a desktop? Okay. You have a laptop but no desktop. Couple people. How many of you have a laptop and a desktop? Many of you. How many of you only have a desktop? It almost counts. Okay? But that vote would have been upside down 10 years ago. A lot of us would have just had desktops. Okay? So what you're seeing a paradigm shift in how people use computing. Microsoft will never lose their hold in desktop or laptop operating systems. But what you'll see computing shift away from that, and that will just get left behind. And then we'll have a new class of computing machines. Maybe it's moving towards tablets, maybe it's a hybrid, but I think what you're going to see, I mean, the clear direction we're going is that some evolution of our mobile operating systems today, so iOS and Android, some evolution of that is going to find that sweet spot that lives between the iPhone, the iPad, and our laptop, or the Galaxy S6 Android tablet and your laptop. It's going to find that sweet spot in there. But what we'll actually be interacting with is the evolution of that mobile operating system, not an evolution of Windows. Does that make sense? It's not that Windows lost. It's that we've replaced the idea of desktop computing with mobile computing.
That's the reason why Microsoft's concentrating more on Windows 8 nowadays, because people are more familiar with this. They'll prefer using a Windows 8 tablet instead of Mac.
Well, sure,
That's
but
what they did with Office.
fine. But do you think that Microsoft has any chance of catching Apple or Google in terms of the of mobile install base? They missed the boat.
You're just trying.
They missed the boat, but they have to try. They have to try.
But don't you think that Microsoft is trying to make the Windows Phone very close to the Windows desktop today?
Well, absolutely. They're trying to create the hybrid experience now, hoping that they can keep people, hoping they can keep people in that world. Where Microsoft still has a little bit of a stronghold, but they're losing it every single day. They've actually lost a lot of it in the last 3 or 4 years, is an enterprise. So the idea is that if you are already working in a company, and the company is all Microsoft, and now they can start giving you the tablets that are also Microsoft, and they seamlessly integrate with your desktop. That's maybe beneficial. But now all of a sudden you're getting enterprise level support from both Android and iOS. Apple did it first. Apple was all about let's get into the enterprise. That's what put BlackBerry. That's what killed BlackBerry, right? All enterprises used BlackBerry before iPhone. And then even when iPhone first came out, the big complaint was, yeah, it's great for consumers, but we can't do any of our enterprise email stuff and things like that with it. BlackBerry owned that market. Well, then what did Apple do? They went out and made sure that every single one of the Forbes 500 list had iPhone support. Well, that doesn't do a real great thing for BlackBerries. Okay. Huh?
They get money from cables.
Oh, patents, sure, yeah, well, whatever. It doesn't matter. It's not that BlackBerry sucked. It's just an evolution. Someday, whether it's Apple, whether it's Google, or whether it's some company that hasn't been invented yet, or just in its starting phase, they're going to come up with the next evolution of computing. The thing that supplants our idea of mobile today. Maybe. Well, actually, I think it's going to deal a lot with nanotechnology. So I can imagine, right now we keep thinking our devices keep getting smaller and smaller and smaller, and now they're starting to get a little bit bigger but more functional, right? So this is the 6 Plus. I realize it doesn't look as huge because I'm kind of big, but trust me, this is the gigantic iPhone. Some of you, how many of you didn't know that? Didn't know this was the 6 Plus? Just because of how big I am next to it. You thought it was a 6? Yeah, no, it's a 6 Plus. You can come check it out if you want. I seem petite, but in real life, I'm actually huge. I'm like the size of like a medium-sized grizzly. I've looked it up.
That's Note 4, okay. He has a big one too.
Yeah. So his Note 4 probably looks huge in his hand. It would look like a pocket phone to me. Does your Note 4 fit in your pockets? Okay. Yeah, I have a couple of friends who got an iPhone 6 Plus. They're same size phones. Note 4 actually might be slightly larger. I think mine's 5.5, yours is a 5.7. Whatever, they're just huge phones, right? That's the whole phablet thing, right? But a couple of my friends are littler guys. They won't fit in their pockets. And that's where you had some of these things about them bending. The Apple bend gate. Well, hey, if you're wearing skin-tight jeans and you stick anything that's, thin enough in there, you're going to bend it because your thigh is going to, right? No, so I told him you got to get some fat guy pants. Okay? I could put a stack of these in my pocket. Actually, I could put an iPad mini in my pocket. Yeah. Full-size iPad can't quite get it. But I can get a mini in my pocket.
Let me ask you a question.
Sure.
A long time ago, they had the Sony PDAs. Remember those?
Sure.
The trend went from the bigger, I know they phased out, the smaller. Now we're going back to bigger. What is Sony going to do about that? What do you think?
Well, what's Sony going to do about it?
Or whoever, yeah.
Well, Sony's dead as terms of a mobile thing. But I don't think we're taking a step backwards by going bigger. I think what's happened is the evolution of mobile computing is now merging. I think it's really what we just talked about. It's merging with the way we compute at our desktop level today. we're getting so close to being able to. I mean, she's a good example. When we asked this question about who has a desktop and who has a laptop, she didn't want to raise her hand for the laptop because she doesn't see a need for a laptop because she has an iPad. Right? The iPad has become the new laptop for many people.
It's already come out, like the Ubuntu phones,
Mhm.
Linux phones. You can actually put it on a dock and use it on a
Sure.
computer.
I mean,
The quad-core and
Sure.
Linux,
realistically, the only thing I use my laptop for is programming. That's it. If I didn't have to write software, I could do everything else that I do on an iPad. Everything else.
Just have to put more cores in the iPad now.
I mean, yeah, more. I mean, you only need more cores if you're doing more than one thing at once.
Make it more powerful.
Yeah, yeah, but power's only there if you need it. So that's like taking we're gonna get a V8 truck, and we're gonna put whatever, superchargers in it and all this crap. The thing's gonna just have ridiculous horsepower. Okay,
You just need
okay, we're gonna do that, but I'm gonna say you can never go more than 5 miles an hour. Okay, so you have all the power in the world, Okay, or we're gonna put jet engines on a Honda Civic, and you're never actually allowed to take off. Okay. See, a lot of people don't. And that's kind of another thing. You don't think of jet engines as being. I mean, you know they're powerful, right? You don't really think about how powerful they are, because airplanes are big. If you put a car next to a jet engine, the jet engine's bigger than the car. Those things are putting off a lot of thrust. So yeah, it's I saw I think it was on an episode of.
They put jet engine in a car like 10 years. I mean, it's still there.
Yeah. It was. Yeah, I saw some Jay Leno thing. Yeah, but I think it was on the show MythBusters.
Yeah.
They had the storm chasers, guys who had their their vehicles, especially designed vehicles that can't get destroyed, and they had that sitting behind a 747 engine. And first they had just a normal car sitting there, and the car just blew 300 yards away. Okay, a car just blew up in the air from the thrust of this engine. Well, then they took one of the storm chasers thing and it slid some, but it held because the power directed it down, so it just pushed it onto the ground. But so it didn't actually flip over or anything. But
there's a car called Trust 1 and Trust 2.
Okay.
Top speed record it was 15 years back, 1,250 kilometers per hour.
Okay.
Top speed of the van.
Kilometers per hour.
I mean,
You and your made-up system.
Yeah. British.
Okay. So in any case, so you asked the question is where's our technology going? I don't really think we're getting larger again. What's happened is we've redefined what we use these devices for. We go back 5 years, we use these devices for making phone calls, for texting, and now there's some apps. Okay? But now these apps are getting more and more complex, and the things that we're using our smartphones for or our tablets for are things far in advance of what we used them for 5 years ago. So now we start needing the bigger screen so that we can see all the crap we're doing. Right? Does that make sense? So it's not that this is going in the wrong direction. It's that we need the larger screen to experience what we're using this for, because now we're not just using this for 1 hour a day. We're using this for half the day. Half our productivity is on this. You see what I'm saying? You can do everything on this. So.
My son, he writes papers. He has a Samsung
Okay.
on his phone, and when I saw him, I went, "No, well, not in a bad way."
He writes it with a phone keyboard. He has a Bluetooth keyboard or something.
I don't know what. I'm like,
I mean, because there are, like my wife, when she takes notes at church meetings, she has a Bluetooth keyboard for her iPad mini. So she can sit there and type at full speed, as opposed to the on-screen keyboard.
I don't know what he was writing a paper for school.
Like that.
And I was like, "Come on, man."
Yeah, that's not productive, right?
You can do everything in your phone now.
Okay. But the reality is, where I think things are going, what's the next evolution?
Programming it.
Yeah, but there are actually interpreters for it, but you probably wouldn't want to do it for productivity.
Linux and for these things, you could just put up the terminal and run aircraft and hack Wi-Fi passwords.
Yep. But so where I think things are going is dealing with nano computing. I think that computers will actually disappear. I don't think we'll actually carry around devices like this. I think there will be the screen will actually be we'll see in our eyes. Okay, so we'll go into screen mode, or maybe one of our eyes has a contact lens in it or something like that that actually becomes a screen. But the computation power will be maybe housed in our clothing. So you'll actually have your shirt might be a computer. Or maybe your wallet will be a computer, or with nanotechnology, you can actually have machines that are microscopic in size.
I've seen that
So
prototypes. I mean,
yeah, so this tie could be a supercomputer.
Yeah, can be.
And the idea would be is now the things you were wearing anyways are now your computing devices,
Okay.
and you're going to be experiencing the screen as your eyes. Why use your eye to look at a screen when you can just
Right.
have the screen in your eye?
How about Google Glass?
Huh?
Google Glass.
Well, Google Glass is just is part of that natural evolution in that direction. It's not a good product in terms of usable, but it's where things are going, and you need a place like Google to take a step. Like for instance, Apple would never do that,
Yeah.
okay? Because Apple would look at Google Glass and say, this doesn't work, so we're not going to release it. Google instead say, hey, let's throw it out there and see what people do with it. If nothing else, it becomes the next evolution. I have a pair of Google Glass at home. They're just sitting there.
What did you think about them?
They're cool for 5 minutes.
They don't have many functions. That's the thing.
Yeah, it's limited for how much functionality you can use them for, and also the battery life is crap. But it helps you see where things might go.
Yeah.
You believe that at some point,
Evolution.
you will be doing your computing, whether it's in my glasses here. I mean, part of the problem is it was just not comfortable. So, if I could have it embedded in these glasses and this, maybe this lens just goes computer screen or something, fine, whatever. But even though the technology that we have today doesn't deliver the experience that we believe in today, we could still say, okay, I think this is where things are going eventually. Okay? And that's really the role Google plays, I think, in today's technology. Apple would never release something like that.
I saw those contacts that you're talking about.
Mhm.
It was built by MIT 7 years ago. I was in a video conference long back 7 years
Yeah.
ago. My undergrad. So they have built-in solar panels under their transparent contacts,
Mhm.
which automatically charge them,
Mhm.
and they have an RFID camera.
Sure.
It's transparent. It's center tech.
Yeah, so when you put all these things
Okay.
together, it's eventually going to turn into our next evolution of computing.
But it's expensive. That's the thing. That's
Well,
why
everything's
we're
expensive.
gonna bring it out.
That goes back to our Y2K problem we talked about. RAM used to be crazy expensive. Now RAM's dirt cheap,
Yeah.
right?
I had a 64. It's around 128. 64.
Well, the example I always use is I had a computer that had 8 megabytes of RAM. I doubled it to 16. It cost me $1,000. Today, if you get a brand new computer from Apple that has 4 gigabytes of RAM and you want to put 8 in there, $60. Done. Okay, unless you order from Apple, then it's $150.
Yeah.
Okay.
Apple's more expensive.
Yeah.
Chinese RAM is cheaper. Chinese RAM is more cheaper.
Oh yeah, Apple just marks up their stuff, and that's fine. They've tested the RAM to work well with their stuff, and then they'll warranty it and all that crap. Yeah, they're all using the same stuff. They're all using the same stuff. All right. So, in any case, we're seeing a lot of comparisons as we're going through this. So, when we made our transition from C to C++ and Objective-C, it was because human beings started hitting the limit on C. C no longer allowed us to solve the problems that we could imagine solving leveraging the way human beings solve problems. Remember, the job of a programming language is to emulate the way we solve problems. And we solve problems in terms of objects. In the early days of programming, we didn't really miss that because we were solving simpler problems. So we really didn't need to represent things as objects because, okay, I only need to hold a couple of pieces of information. But as our programs got more and more complex, and then as the world of the internet started opening up, now our programs today are far more complex than they were 10 years ago. Hundreds and hundreds and hundreds of times more complex. Okay, from 10 years ago. You roll back to when C was, the programs that existed that were written in the early days of C were like equivalent to our Hello World programs today, relatively speaking. I guess I'm just kind of, trying to show you that stretch there. So we needed these newer languages. So this is Apple, this is Microsoft. They split here, but both of these are object-oriented versions of C. The evolution from C++ to Java removed structs. Because Java decided, you know what, we can really accomplish everything we need to do between structs and classes in terms of classes. What's a struct? A struct is, still going by the way. Okay. What's a struct? A struct is a class that doesn't have any methods defined in it. That's it. So if you want a struct, make a class and just don't put methods in there. Right? So why do you need to have a struct in a class? You don't. So that's been Java's MO for years. You know, that's Java's thing. Java looked at the existing popular language, C++, and said, you know what, C++ has done a whole lot of things right, but let's see what we can do to streamline it. So they took away some of these things like pass by value versus pass by address. They took away the idea of a struct because now you can represent anything you could have done in a struct as a simple class. And anything you couldn't have done as a struct, they just brought over C++'s class architecture and even made that a little bit better. C++ actually had a pretty big weakness in their, I'm getting a little ahead of ourselves here since I'm just introducing objects today, and we'll talk about it a lot next class, but C++, in object-oriented languages, we support something called inheritance, which we're going to talk about probably next class, maybe next class. But C++ actually supported double inheritance. So you can have one class inherit from two separate classes. And that actually caused a lot of problems because there could be conflicts. And that'll make more sense when we talk about it, but that was something that Java took away. Java said double inheritance doesn't exist. If you needed to inherit from two different things, you would have one guy inherit from the other guy and then have this guy down here inherit from this guy, who then inherited from this guy. So it would be a linear inheritance rather than a direct inheritance from two different sources where you could have conflicts. You know, do I have blue eyes or brown eyes? If we're thinking about this in terms of human things. Okay, so makes sense for genetics. You know, God could figure it out, but language designers maybe couldn't quite swing it. Okay, but really the purpose of Java was to evolve C++, but it didn't evolve it from an object-oriented language into something else. It evolved it into a better object-oriented language. Okay, better is fair enough to say. Some people might disagree with that, but I think it's fair to say Java made improvements over C++. You might have some old C++ programmers who are missing a couple of things, but for the most part, I think things are better in Java. C#, same as Java. So C# was an evolution of C++ as well, but really C# just took everything that Java evolved, and then they even evolved a couple of things. In fact, C# actually gave those old C++ programmers back a little bit. If you want to work directly with memory, you can through an unsafe code block. So, C# basically said, look, we understand that you're pissed. We're going to give you a little bit of that back, and we're actually going to upgrade the Java architecture a little bit to make our programs run a little bit higher performance. Okay, and we talked about that earlier in this course. So we're seeing an evolution here. But now what's funny is over on the app side of things, or the Apple side of things, when we typically think of Apple as being innovative, they were archaic. ObjectiveC to ObjectiveC 2.0, really nothing. This was a much, so if we're putting ObjectiveC 2.0 in the same line as Java, this guy was much, much less modern than Java. Much more archaic. A lot more verbose, things like that. So we would have said that this guy was really dragging behind here. Swift is ahead of all of them. Okay, so Swift was their real first innovation in languages in a long time. Okay, and Swift is actually very interesting. And I don't want to spend, I could spend a couple minutes because I at least want to introduce the basics of objects to you so you can do your homework. But you only need the basics to do your homework. But Swift becoming an evolution, which is related to what we're talking about. We're talking about the evolution of languages. What it did is it basically said, we are abandoning the Objective-C syntax. Swift is not based on top of Objective-C syntax. Swift looks a lot more like Java and C#. Okay, looks a lot more like these guys. So now we're over into we've moved what I call the big three into a little bit more of a linear line here. Okay, but one of the major, and this is actually the thing I really like about Swift, so I like bragging about it. Swift's main goal, if we had to say there was a main goal of Swift, it was to reduce the amount of programming, the amount of syntax the programmer had to write. So kind of what Java's goal was. Let's not make the programmer write stuff that they would always do that way. Make sense? So let's not always, let's take away anything that should just be hard-coded and just will always happen. Let's just put that into the language instead of making the programmer write it. So Swift said we're going to do that as well. So that was Swift's major goal. Is anything the programmer is used to writing but really doesn't have to write, we're going to take that away. Okay, for instance, variable types. When you define a variable in Swift, you say something like var a is equal to 5. And actually, no, it's not semicolons. So that's defining a variable in A. Right off the bat, we might say, oh, that looks like a loosely typed language. What happened is, when I put a 5 in there, this guy became type int. If I had put a 5.0 in here, it would have become a type double. So if right after that in Swift, I would say A is equal to 3.4, it would yell at me. This guy's of type int, not of type double. Okay, so they took out the variable type stuff. So now defining a variable always requires you to say var. Var, variable name, equals value. And it determines what kind of value that variable is based on the value you put in there. Okay, so little thing there. But here's the kicker. This is the part I love. Love this part. So again, remember, Swift took every single opportunity to minimize the amount of stuff that the programmer had to write. Okay? Now, syntax for an if statement in Swift. If, actually, you don't even need the parenthesis. If Boolean expression okay, if Boolean expression, curly braces are required. Okay, remember when I said that the curly braces are actually optional in Java, right? But I showed you some examples of, okay, you're never wrong to have curly braces, correct? It's never wrong to have curly braces because what's following an if statement is a single statement. Okay, what's following a loop is a single statement. So if you understand what's the difference between one statement and a group of statements, that's fine. But I said you're never going to be wrong putting curly braces in there, correct? Swift requires them. So this language that has made every single effort to reduce the amount of stuff that the programmer has to type has specifically decided the programmer has to type curly braces. Not optional. I just find that, I've been saying that for years. Okay. Oh, designer of Swift? No, my background's in programming language design. I teach our language theory course, but yeah, I don't think I'm designing any languages anytime soon. I think they're doing a good enough job. I like the teaching the easy stuff now. Languages are really cool, but when you're designing a new language, you really have to be forward thinking, and it's fun to think about. But when you actually go to write it, you're making guesses as to what you think is an improvement, right? Which is a good reason maybe why Apple took so long to bring something out. Really, Swift has two reasons, okay, that it exists. One reason is, well, ObjectiveC was very archaic, right? The other reason is that, well, another reason would be that ObjectiveC looks a lot different than our other languages. Not like night and day, but definitely different. If I can just bring up an ObjectiveC program real quick. Oh, this would be good enough. This is one of my iPhone apps. Okay, so here's a little bit of ObjectiveC code here. This is just one of my iPhone apps. First of all, one thing you'll notice here, I would say this is a relatively simple app I'm working on here. Now, where we're kind of going in Eclipse here, notice this thing's still working, is all of our programs up to this point have always been one source code file, right? Driver.java. Well, we're going to be jumping to have two source code files for this assignment. Okay, we're going to have a fraction.java. Okay, now look at all these source code files. That's in one project. Okay, and I would say a simple project. Now, just to give you an idea here, right here we're creating an instance of a variable. So the equivalent of this in Java would have been AV is equal to a new UI alert view, something like that. So this line and this line would be equivalents. This is what I have highlighted now is the Java version of that. So you can see that Objective-C actually looks a little bit different. Okay, and actually when I say this line, I'm actually sort of kind of lying because this line right here is actually that whole line. So this guy takes a title, a message, a delegate, a cancel button, and other buttons. So actually this guy takes a couple of parameters. So we're going to say error, you must fill in all the fields. This and okay. So all this stuff, this would be the Java equivalent. This is the Objective-C equivalent. But the biggest thing is Objective-C uses a lot of these square bracket syntax, which actually in the end I like better. Because when you're calling this method here in Java, this guy takes, as I have it written, 4 parameters, right? Like this, it's a string, a pointer to myself, and another string. But we don't know what those strings are for. If you look at the syntax for Objective-C, we are creating a new UI alert view, that's the equivalent of new, and we're initializing it with a title, error, a message, you must fill in all the fields, a delegate, that is myself, a cancel button title, which is okay, and all other button titles. It's very verbose, but it's also very expressive as to what the parameters are. Okay, so when you first start coding in Objective-C, you're like, oh my gosh, I'm having to write a lot of code to pull off what I want. But at the same time, it's like, it's a lot of times more self-documenting. You know, when you look at the code in use, you know what all these things are for because it tells you, it gives you a little blurb beforehand. This is part of the syntax, init with title. And then I'm going to pass it a title, as opposed to it just expecting a generic string. All right, so in any case, we can see that Objective-C, while still very much a C-based language, you know, a lot of this stuff looks the same for us, if statements and for loops and defining variables and all that stuff. Here, I'm sure we can find an int somewhere in here. Well, here, int I is equal to 0. That's Java, right? It's the same to us. I is less than the number of elements in something, I++. These are all things that are familiar to us. But the language itself is a little bit on the archaic side. So it was very old. So what did Apple do? Apple said, you know, we need to innovate, so we're going to come up with a brand new language. But they didn't come up with a brand new language because they thought Objective-C was insufficient. Because all the people who are currently writing iPhone apps were perfectly happy with Objective-C. Okay? I actually like the language. I think it's a very good language. Bigger issue is Apple looks out at the rest of the world and says, look, who's our competition? Our competition is Google, right? Fair enough. It's good. That's really good for us. You got 2 top-tier companies that are in competition with each other. Nothing wrong with that. Nobody has anything legitimately bad to say about Apple from an innovation perspective. Nobody has anything legitimately bad to say about Google from an innovation perspective. You could talk about business practices all over the place, but both of these companies are great technology companies, right? Well, the people who are writing apps for Android, for their mobile platform, are Java programmers. Do you think there's more Java programmers or more Objective-C programmers? A lot more Java programmers. Now, there's more Objective-C programmers today than there's ever been before. You know, when iOS came out and they released the App Store, the number of Objective-C programmers went from this to this. Okay? But still, this pales in comparison to these people who've been writing Java for years, right? Because before the iPhone App Store went live, well, even not just live, before it became popular, okay? Before it became popular, the only people who were writing in Objective-C were people who were writing Mac applications, right? Which is a very tiny percentage of the population, because Microsoft had the lion's share of all the desktop world, right? So you had, let's say, I'm going to be real generous, because I think this number is way lower than this, but I'm going to say less than 5% of all developers programmed in Objective-C. I actually think it was far less than that.
Apple was going to sell out everything.
Oh yeah, that's a whole nother story.
Everything changed.
Yeah, that's a whole other story. But, even when Apple was back on its feet, the iPod was out, they were a top tier company, they were making a lot of money. Still, a very tiny percentage of the population programmed in Objective-C, because Apple was popular for their music devices. Okay? Secondarily, they were popular for their computers. Make sense? The people who had Macintosh computers were Apple fanboys, right? Everybody else was using PCs because that's what was compatible with the rest of the world. But if you wanted to have a music device, you had an iPod. Okay, I don't care how how many of you were PC users who also had an iPod? You're a PC user. We're even rolling back. I'm talking back when you went from the early.
8 years ago, the first
Yeah. Everybody had an iPod. If you listened to music on the go, the only device worth having was an iPod, right? There was a couple of holdouts, right, that said, "Oh, well, I'm going to stick with the Sony Walkman." Yeah.
More memory. Apple offered more memory, 40 gigs.
Yeah, but who cares?
That's why we.
Yeah, the bottom line is that it was the better device. Bottom line, it was the better device. So Apple was a music company, right? Mobile music company.
An internal charging battery. Most
Sure.
of those players in those days.
Mm-hmm. So what really happened more recently is now with the iPhone and the App Store being popular, now they've brought in a whole bunch of developers who are now using their languages. So all the people that originally jumped ship, who came from other disciplines, Java, something like that, to come over to write for iPhone, I mean, a large percentage of those people were not Apple developers beforehand. They're like, hey, let's go make some money on the App Store. Okay? They've already learned Objective-C, and probably like me, they like it after they've gotten past the learning curve. Okay? So what's Apple going for with Swift? All of these other guys. Okay? You know what? All you Objective-C programmers, go ahead. Come and learn our new language if you want it, but you know what? You could still write your iPhone apps in this. Okay? It's going to be in our best interest to learn Swift as Objective-C developers, but really, there's no rush. But you know what? Hey guys, all you Android programmers over there, you like your Java? Swift looks a lot like it. And oh, by the way, we're actually more innovative now. We are actually a newer evolution of programming language. We're better than these guys. Come try us out. Okay, that's this group. Then, this gets even better. Man, we're going to run out of time. Jeez, I have to keep you until 11. Is that okay? Then you had these guys. You had the PHP developers and the I don't know. Yeah, we'll just say that. PHP and Perl. We'll throw a nod to the Unix guys. All right. So these languages, these are loosely typed. Here, actually, better one. Ruby. Yeah, let's go Ruby. So our web programmers over here. Okay. So these are guys. Oh, we don't mess with Java and C++. Those are too hard for us. They're too difficult because we're stupid. Okay. We're lowly web programmers. We're half designer, half programmer, right? That's kind of the dividing line. That's the premise, right? That doesn't mean that web programmers aren't great programmers. Many of them might be a lot better than some traditional programmers, but generally speaking, the guys over here are hybrid skill sets. These guys can program some, but they can also make stuff look good. They're designers as well. Okay, where you take a Java programmer off the street, this guy might not be able to draw a picture, okay, by hand, okay, like a crappy picture. They have no artistic skills whatsoever, but they can code. So these guys are a hybrid skill set. And typically, these languages are considered simpler languages. I don't really agree with that, but let's just say they are, okay? But these languages are based off of C as well. Well, Swift, just like the variable stuff, looking like a loosely typed language. Hey guys, how you doing? You like your PHP and you like your Ruby? No problem. Swift looks a lot like that. Why don't you come over here to the dark side and start writing iPhone apps? All right, so Swift is the gateway drug that Apple has put onto the market to pull Java and C# programmers to the iPhone side and pull web programmers onto the iPhone platform. Because what's starting to happen is what we've seen happen over the last several years is you have these cross-platform tools that have come out. That is, somebody can write an entire mobile application in JavaScript or in Python, and the tool deploys it for both iPhone and Android. Okay? But you don't get a very polished end product because that tool had to do it in terms of the lowest common denominator between those two devices. So they had to take and this isn't a knock on Android, but they had to take the Android's lowest common denominator because the Android operating system is built to run on a whole bunch of different devices. That's why Android apps tend to look less polished than the iPhone equivalent of the app. It's not because Android sucks. It's actually Android solving the much more difficult problem. But iPhone, they control the hardware and the software, easier problem, stuff's just better. Okay? It's shocking how good Android is. So those multi-platform tools, what they're doing are the cross-platform tools. They're taking the stuff that can only happen on all of these devices. So maybe it's, instead of, let's say iPhone's here and Android's here. But let's say the lowest common denominator for both of those is actually here. This is where they're equivalents. Okay, anything above this, maybe Android has a couple things iPhone can't do, and iPhone has some stuff that Android can't do. So they got to drop below that and just do, this is the equivalent. This is what they can all do this stuff. So now you're solving all your problems using this cross-platform tool in terms of only the things that both devices can do. And you're using a language that web programmers and stuff like that are already familiar with, whether it's JavaScript or PHP. A couple of them are PHP, Ruby, Python. What would be another? Actually, more recently, HTML5. Yeah, now all the mobile apps are done in HTML5. So now you have web programmers creating these left and right. Well, HTML5, while a great modern rendition of HTML, is nowhere near as powerful as our modern high-level languages. So if you're talking about what kind of apps you can deploy in Java, C# or Swift compared to HTML5, it's no competition. But the reason apps are being done in HTML5 is because the people who have that skill set to make them look good and make them work are these web developers over here. Okay? So Swift is trying to approach both of these guys. Let's drag some of those Android programmers over to iPhone. Let's drag those guys who are doing cross-platform stuff over to native iPhone so that we can have better apps. And who cares if Android dies? They won't. They won't die. Don't feel bad, right? Okay, more than likely, what I think you'll see happen, here, this is a prediction. You're going to see Google continue to evolve their Go programming language. And you'll actually start writing Android apps in Go. So you'll see this being the next evolution. Quote me on that. Quote me on that. I bet you within the next year, I'm going to put a time limit on it. Within the next year, Google will make a big push where you can start writing Android apps in Go. And Go already exists. This is a language that already exists. It's an internal scripting language for Google. But they're going to evolve it in terms of what Swift has already done and probably, put a couple little extra hooks on it, kind of like the C# to Java stuff. Okay? So that's where things are going. Now, what I need to do in our last couple of minutes is I need to give you this initial framework for creating an object. We're giving up on this guy. Okay? It's been almost 2 hours. Okay? So we're going to time complexity problem, right? You get it? So what I'm going to do here is I'm going to create another class. Now I'm not going to actually create a fraction class. I want you to do that yourself, but I'll give you an example of something that you could base yours off of. So I'm going to create a new class. And this guy is going to be called person. Okay? And we're going to say a person has a first name, and a last name. Right off the bat, we might say this is a struct. Okay? Okay, and I'm probably going to go a little quick here at the end, so you might want to rewatch the video because I spent too much time babbling. But I guess just deal. I'm going to get rid of all this crap because it's useless, right? All right. So I created this other class called person.java, but I'm using it like a struct. Okay? And notice it's in my same directory, so now I have driver and I have person. So out here in driver, I'm going to say person p is equal to new person. So I'll create an instance of that guy. And then I'll say p dot first name is equal to Mike. P dot last name is equal to Lippman. Make sense? Now I have a single variable named p of type person which holds two different values. Now I can come in here and I can say int age and I can say p dot age is equal to 25. I need to pass for 25 to get into this Korean hackathon we talked about at the beginning of class.
Really?
Yeah, you got it. You're supposed to be a student, so I lied about that.
You can fake an
I applied with my CUW email address. So okay. So now I'm holding two strings and an int. So this already bypasses one weakness we have with arrays, right? Actually, two weaknesses. We have a single variable name, which can hold multiple pieces of information, just like an array. But now I don't have to remember what bucket those different pieces of information are in. Now, fname is in a variable called fname. Lname is in a variable called lname. Age is in a variable called age. Make sense? This is Java's version of a struct that it evolved out of C++. Structs no longer exist in Java because the Java people said that it doesn't have to. All right, well now we're going to make this into an object, which in Java there's no difference. This already is an object in Java. But I'm going to say we're going to have a method void display. And display is going to say system.out.println fname concatenated with a space, concatenated with lname, concatenated with a space, and a colon and a space, concatenated with my age. So now I've kind of created a method inside this guy that knows how to display the contents of a person. All right? So now this guy's evolved from a struct to a class. The C++ equivalent of a struct to a class. In Java, everything's a class. Because now, this guy, is this a class method or instance method? Instance method. How do you know? No static. So now I can say p dot display. And it'll display my dude. Okay? Similarly, we can create constructors. And I'll go into all this stuff in detail next class. I'm just giving you a template to work off of for your homework. Okay? So for your homework, just modify this guy to work for fractions. All right? So we're going to go ahead and we're going to create a constructor. Person. And this guy is going to take in an int. I'm sorry, not an int, a string. A string fn, a string ln, and an int a. I purposely made these different values than these guys up here, different names, because I'm not going to introduce this keyword yet. We'll talk about it a lot next class. So just forget I said it. All right? So for right now, your field names must be different than the names coming in, otherwise you won't be able to distinguish from them. For instance, if I say fname here, and I want to set fname equal to fname, we don't know which fname we're talking about. Okay? So I'll explain that in a lot of detail next class. For right now, we're going to say fname is equal to fn. Make sense? FN's this guy, FName's this guy. Similarly, LName is equal to LN, and age is equal to A. Make sense? And I'm going to actually make these guys private right now. Actually, before I do that, just give me a second just to show you this. Oh my gosh. Time is not my friend. I'm just going to delete this real quick. I'll put it back in 1 second. So instead of calling display, I can say system.out.println p.age. Like that. I can directly access variables from my struct. All right, so this will just print out the age. All right, now when I go back in here, I put that back out there, your assignment talks about making private variables. So for right now, we're going to make these guys private, and we'll talk about that in a lot more detail next time. But as soon as I do that, actually let me keep this out as well, just for right now. We're going to see we have errors over here. P.FName is no longer accessible because it's private. It's only accessible inside of this class. So I've taken away that feature that structs used to have by making it private. I cannot directly access this variable. I cannot directly access this variable. I cannot directly access that variable. So if I want to set the first name, the last name, and the age, I actually have to do it through a method. That's where that constructor comes in. So now I have a constructor that takes in a first name, a last name, and an age. So now I can build this guy. Instead of using the generic constructor, I now have a constructor that takes 2 strings and an int, and I'll pass it Mike. Littman, and 25. I'll pass it those 3 pieces of information. So they're getting passed in to the constructor. And then I can say p.display. So the constructor is expecting a string, and an age, and an int. It's setting our 3 fields, these private variables associated with this class. And then I have this one method called display. So outside here, when I create an instance of person, Mike Littman 25, and I say p.display, it shows me that information. If I then create a person P, P2, and let's make this my brother. Okay, and if I'm 25, then he's 23. Okay, and we'll say p.display and p2.display. And now we'll say P's display method shows his stuff. P2's display method shows his stuff. Make sense? All right, so that is a simple crash course introduction to objects. We haven't really done anything special. All we did is take a lot of the stuff that used to be in main, that used to be in our driver class, and now we're sucking it into another class and then using that object out here. We no longer see all the wires of our telephone. The wires are now hidden in here. Okay? So when we look at this, we're just using those objects. That makes sense? All right. We'll talk about objects in a lot more detail next time. Let me just quickly read through the assignment, make sure there's no quick questions. I apologize for going over a little bit. So programming assignment. Create a fraction class, very much like the person class we just made, that has 2 private fields, a numerator and a denominator. We currently have 3 private fields, a first name, a last name, and an age. A fraction should be able to display itself. We currently know how to display a person. You're going to write your own display method for displaying a fraction. It should be able to add itself to another fraction. So you're going to have to write a method called add that takes a fraction as a parameter and then adds those fractions to each other. Okay? It should also be able to subtract 2 fractions from each other. So you're adding subtraction to this. Okay, so you're practicing with objects, but adding stuff together. Okay? Now, the one hint I'll tell you here is for those of you who've had some object-oriented programming before, for this exercise, you really don't have to worry about the fact that these are private, since you will always be accessing the private variables inside the class called person. It will be allowed. So for right now, don't worry about the private aspect of this too much. I'll explain it a lot more next time. Just know that by these guys being private, you cannot directly access them out here in main. But inside the fraction class, when you have your add method that takes in a fraction f as a parameter, you can say f.numerator, f.denominator, because all of those are inside of the fraction class. It's allowed. Okay? So that is the program. The paper, and this is what we were talking about earlier, that I'm hoping that some of you catch on to. Write a 3 to 5 page paper discussing the role of computer programming in the IT industry. Okay? You can read on to the rest of that, but I want you to look at why what I'm teaching you in here is actually important for IT people. Okay? Not just computer scientists. Just like I say in the beginning, computer science and IT are opposite sides of the same coin. Computer science is 80% creation, 20% using what's created. IT is 20% creation, 80% using what's created. Well, that 28% creation is programming. All right? Questions, comments, concern, bribes?
Next week is the last week.
Is it?
The last class, and week 8 we just have to take the exam, or we have to take class 2.
Let's see. Okay, last week. All right, we will have we're going to spend most of our class next time talking about the rest of the stuff. We will have a short exam the last hour of next class. I will send out a study guide. Next week's our last class? Oh, okay. Oh, I got you. Then we'll talk about it next week. I haven't written the test yet. Written the test. Okay. Oh, that's the problem. The week after that, spring break.
Yeah.
All right, that is going to be a problem. We'll figure it out because I will not be in this state.
Yeah, you told us. I'm just reminding.
All right, we'll talk about it next week. All right, I apologize for keeping you late.
So do we have to keep you? No. Do we have to send two?
Yeah, when you submit, submit 2 separate files, or copy them both into a Word document, or you can paste all the code into the single window. I'll be able to figure it out. Just don't submit 2 .java files. Either zip them, or call them a .text. Just Angel doesn't like .java files. All right. Next class, we have some time. I'll introduce you to a tool called GitHub, which allows you to more easily share code and stuff like that. But somebody remind me about that too. All right, I'll see everybody next week.